Hello YouTube, vintage stereo collectors. And here is another one of these Nikkos. This is a Nikko TRM-40 version A. It's the early version. And there's actually some documentation on the internet out there shows this is a 63-64 model. Now that is early, really early for stereo solid state. And here's the thing about products. If you're going to bring a new product out on the market, it should do something better than the previous products. One thing it did better, it was smaller and it ran cooler. And it sounded as good as tube units. And these had a very tube-like sound. And a lot of that was due just to the engineering. And how can I explain it? Maybe our expectations were as high for power, but sound quality, what can I say? The person that bought this back in the day, it would have been pretty cool to show this off to your friends. And look at the build quality on it. These knobs are machined aluminum. They do not have plastic inserts, which is really neat. And they just turn so nice. They're Alps controls. And just like earlier cars, it's mainly metal with very little plastic. Just the inserts to the switches are plastic. So there's a stereo mono, loudness, rumble filter, scratch filter. Doesn't have a headphone jack. The Model B does. It's one of these ones that uses interstage transformers between the driver stage and the output stage in order to basically match to split phase and to match the components. That was later solved in just a few years. I'm just going to give you a tour around it. The preamp board's over here. Good feature is that the selector switch is at the end of the shaft here, just like an inch away from where the RCA jacks are. The RIAA equalization's right on the selector switch, which in theory should make it very low noise. What's going on now is the germanium transistors are particularly noisy, especially after this age. And I find the Japanese germanium transistors were longer lasting, but they do succumb to the same problem. Crystals grow inside them, and they eventually short out or get noisy or just quit working. So there is a remedy to that, and we're going to go into that in a couple of videos. The back of it, so it has RCA jacks. It has a bakelite terminal strip. Unlike the later Nikkos, it does not have the interlock. The cord goes straight into it. I actually have a new old stock cord that I think I can replace that with. I'm going to look at some options on this. Switch nuts, switch outlets, they're not broken, luckily. Fairly decently sized power transformer. I'm just going to flip it up, and this thing is heavy. Yesterday I sold a Toshiba SA300 receiver, and so I carried that one down, then carried this one up. This one was heavier, and it's mainly metal and the two transformers. There's been some work on it. Somebody's put some really decent capacitors into it, so it's been recapped fairly recently. I'm a little concerned. The original 3000 microfarad caps here, these are the main filters, and it's a split rail design, so you have positive voltage on one side and negative voltage on the other. They're 8200 microfarad, and they fit well and everything. I think that's a bit too much, to be honest. Especially with the stock germanium diodes and the rectifier bridge. I don't know, I'm actually going to put a meter on it and start it up, and well, it's not a computer, you don't boot it up. I'm going to turn it on, see how much current it draws. I don't think it'll harm the transformer, but eventually take out a rectifier. Especially if you turn it off then back on again very quickly. Something to look at. These are matched. The output transistors on the back, I've always kind of liked this design. The thinking was you might blow a few outputs. They were a little bit fragile, so you don't have to take the whole unit apart to change them. They are stock Hitachi 2SB33Ts. So that's a PNP transistors, germanium. That's all the heatsink it needs. It's actually a nice thick aluminum bottom, like the whole bottom is the heatsink. And it won't get that warm, it'll get a little warm. And that was one of the selling features, very little heat. Anyway, I had actually put a meter on this and I listened to it for a while. And it was very noisy in the right channel, and it dropped the right channel a few times. And just going around inside of it, I couldn't see anything particularly loose, although these jacks, so we put a cable in them, they don't have a solid feel. Yeah, like, it's not the jack's fault actually. This is something I figured out back in the 80s when I used to get stuff this age coming into the service bench. Early Japanese RCAs were a different size. And I'd see this on stuff. You know, you'd plug in a phono to check in, you know, like a lot of those Pioneer SX34 tube receivers were like this. And you go, that's so loose. And you'd end up with intermittence and noise. And then the sales rep for one of the companies, I think it was actually Yamaha, we were talking about this one day, and you know, just what the issues have been lately. And I said I got this real old Pioneer, I want to show it to you. And I showed it to him on the bench. I said, this is the nicest sounding unit. It was 6 BM8 outputs, all Matsushita tubes, and actually made by Pioneer. But I said, it's got the worst jacks on the back. And this guy who'd been in the industry since the early 60s, he said, it's not the jacks. He said, it's a different size. The RCAs on a lot of them in the 60s on the Japanese units where the inside diameter is larger. He said, you either have to crimp the connection inside to tighten them up or replace them. So I'm not quite sure what to do with that. So there's actually a crack on this one here. And they're kind of recessed. I'm going to think about that one for a while because you want the best possible performance. The thing that's going to be the real tackling point is transistors. Matching up some silicon transistors and adjusting the bias resistors. I usually find that you don't have to tweak them too much. Like I've actually done 3 of these before. And there's very little tweaking. The tricky part, I don't know if you can see this, on this board here, there's the 2 driver transistors, 2SB54 and 2SB56. Instead of emitter resistors, there's small peanut-sized light bulbs soldered onto the board. And that was something, I've seen that before. Some of the Night stuff, Night Solid State has it. The Marsland stuff that was made in Canada, they used that for a while. And basically, it's both an indicator. So if one of these blows to short, the bulb comes on, okay? And you shut the thing down. That's a pretty obvious indicator. It also is a buffer to the transistor. And what was kind of neat, I remember I was driving a Marsland M200 into some Sur in Vegas one time. And I basically had the amp full out because it's only a 12 watt per channel amp. And the bulbs were flickering to the music. And you're seeing the current flow through the emitter resistors on the driver stage. Kind of interesting. They're likely, okay, they've likely never turned on. Looks like all original transistors on here. It's been recapped, so that's half the battle. The biggest thing on this one is going to be tracking down noise, because it just doesn't sound great, and it doesn't really, it's not putting out a lot of wattage. I was thinking, well, what could be going on here? Actually, I can show you very quickly. Just be patient. I'm going to plug it in. No load on it. Okay, and we're going to look at the output transistors. I'm going to turn it on. That power transformer is, I can hear it humming inside. Makes me think there might be too much load on it. But let's clip onto the chassis and just touch the collector screws. I don't want to block your vision. Just like that. Oh, okay. 21, 21. So this is one channel, this is another. Come around this side, nothing. That should be positive 21. Now, let's look at the speaker outputs. Let's see how much. This doesn't have a speaker switch or anything, they're just on all the time. Let's touch one channel. So we have 170 to 180 millivolts. That's too much. Oh, this one, 140-ish. That should be around like 10 or 20. That's leakage. There's actually, I believe, a 100 ohm resistor across the speakers as well to drain some of that leakage down. These transistors, they're probably working okay. It's cool. Maybe that one's a little warmer. They're probably working okay for their age. But somehow the one half is not getting voltage. So that explains why it doesn't have very much power. Anyway, I am going to do a little more work, I guess my plan of attack basically on this is to remove these two and go to something close to the original value. That's to spare the transformer and the rectifiers, which I'll replace with silicon, from a harsh turn-on spike. You don't want a lot of current going through there. It's not wired for that. It's not really meant to be souped up. It's a 14 watt per channel, and it's going to be a great sounding 14 watt per channel. What I'm going to do, sorry, I shouldn't say but there's some burning on there. This resistor's been cooking. The output stage is going to need attention. I may end up converting it from PNP germanium to NPN silicon. I did that on another one. These aren't even, that's a bit odd. I'm going to convert it to NPN solid state and NPN. Tongue twister, I haven't had my coffee, okay? I might go with an NPN. It's very easy to do. It's just a reversing of polarity, but it will work just as good. Or you can use the PNP TO3K silicon transistors. And it's just these bigger resistors you have to change. And then work my way back towards the phono stage. See if I can get some of this noise out of it. And then address the jack issue. Anyway, thanks for watching and listening. I will send some updates on the way. If you have an early solid state unit that's kind of the same predicament and you would like it to work its best, stay tuned.